Continuing with section 3, here is a brief summary of mean, median, and mode. Back to the previous paint example. Recall both brand A and brand B had the same mean of 35 months. But we also saw that brand A is much more spread out than brand B paint. This spread or cluster is the basis for variation. Variation, also called spread or dispersion, has several methods of measurement. When rounding with variation, round to one more decimal place than the original data. One measure of spread is the range, which is just the difference between the maximum and minimum value in the data set. The range for brand A paint is 50 months. The range for brand B is 20 months. Which paint would you go with? The standard deviation is a measurement of the amount a number varies from the mean in a data set. The standard deviation tells those interpreting the data how reliable the data is or how much difference there is between the pieces of data by showing how close to the mean all of the data is. The formula for sample standard deviation is shown here. Typically, we will use our calculator to find standard deviation, but it's good to use the formula by hand at least once. For this example, we need to find the mean first. Now that we know the mean, we want to find the difference of each data value and the mean. Now we square each of those values. Now we sum all of those values up. We get 10. Also, the total number of data is n equals 5. Now we just plug in our values into the formula and evaluate. So in our example, we get the standard deviation for hourly salaries is $1.60. Here's some more information on standard deviation. Typically, a low standard deviation means that the data is very closely related to the mean, thus very reliable. A high standard deviation means that there is a large variance between the data and the mean, thus not as reliable. Standard deviation is affected by outliers. Units of standard deviation are the same as the data values. Below are a couple of examples and the meaning of their standard deviations. Also, we usually find the standard deviation using our calculator. Below are the directions for the calculator. The variance of a set is a measure of variation equal to the square of the standard deviation. Below are some facts about variance along with the formula. The units of variance are different from the units of the original data. This makes it hard to interpret variation in the data. Due to this, we typically will not use variance as a measure of variation. Now, let's look at our example of brand A and brand B paints. Clicking Stat on our calculator, then pressing Enter, we can see the data in our list from earlier for brand A and brand B paints. Now we click Stat again and scroll over to Calc, then select 1var Stats. Then hit the second button and the number 1 to bring up L1. And we can see that the standard deviation labeled S sub x is equal to 17.5 months for brand A. Using the same process, we can find the standard deviation for brand B. And we can see for brand B, the standard deviation is 5.8 months. So here we could see the spread of both brand A and brand B paint. We could see that brand A is spread further from the mean, whereas brand B paint is closer to the mean. When knowing the standard deviation, we can find the range of usual values. Finding the range of usual values gives us an idea of what two values most of the data are between. Now let us find the range of usual values for brand A and brand B paints. Recall 17.5 months is the standard deviation for brand A paint, and brand B has a standard deviation of 5.8 months. Also recall the mean for both paints is 35 months. So for brand A, first we find the maximum usual value. Then we find the maximum usual value for brand B. Then we find the minimum usual values for brand A and brand B paints. So the range of usual values for brand A paint is going to be between 0 and 70 months. Quite a big spread, huh? And the range for usual values for brand B paint is between 23.4 months and 46.6 months. The range rule of thumb also leads to a way to approximate the standard deviation. This is found by dividing the range of the data set by 4. If there are outliers in the data, this will cause the approximation to be extremely inaccurate. Let's approximate the standard deviation for brand A and brand B paints. We end up with 12.5 months for brand A as its approximate standard deviation. For brand B, the approximate standard deviation is 5 months. Now we introduce the empirical rule for bell-shaped normal data. Empirical rule states that about 68% of all data falls within one standard deviation from the mean, and about 95% of all data falls within 2 standard deviations of the mean. And about 99.7% of all values falls within 3 standard deviations of the mean. The coefficient of variation for a set of non-negative sample or population data expressed as a percent describes the standard deviation relative to the mean and is given by the formula seen here. Recall, standard deviation can only be used to compare samples whose units are the same and have approximately the same mean. Coefficient of variation allows us to compare data samples that don't meet those criteria. In this example, we want to compare the variation between number of car sales and commissions in a 3-month period. So let's find the coefficient of variation for each. We know the mean for number of car sales is 87 and also has a standard deviation of 5 cars. Mean commission is $5,225 with a standard deviation of $773. So the coefficient of variation for car sales is about 5.7%. The coefficient of variation for commission is 14.8%. Comparing the two, what do you think this means?